Alright, welcome to this new video. As I promised in the previous video, we have to solve 3 examples of the inverse of the Laplace transform, and this case is focused on the fraction decomposition. Okay, so I don't want you to use something else. Please just use the fraction decomposition here. Okay, so for the first example, we have this fraction 1 over s squared minus 1. We have to do the fraction decomposition first before we can find the Laplace inverse, because you cannot find directly this Laplace inverse from the table. Okay, you can obtain the Laplace inverse of this function, these 3 functions, from the table. That's why we have to use the fraction decomposition, and it will help us to obtain the form of fraction that we already have in the table, and from there you can solve it. Then let's start. 1 over s squared minus 1. You know, for the denominator x squared minus 1, we can factorize it in the following way: x plus 1 bracket s minus 1. Okay, and in terms of fraction decomposition, I can choose to write it as alpha over x plus 1 plus beta over x minus 1. Here you have to cross multiply. If you cross multiply, we have this alpha s minus alpha plus beta s plus beta, all this divided by x plus 1 x minus 1. Okay, then if we write the s together, this is alpha plus beta, all this multiply s minus alpha plus beta, all this divided by s plus 1 s minus 1. All right, if we compare to the left side, we see that there is no term here carried by proportional to s, so alpha plus beta is equal 0, and here we have minus alpha plus beta is equal 1. Minus alpha plus beta is equal 1. And if you solve this system, it is obvious, it's trivial. You see that if alpha is minus half, and beta is half. Okay, so once we have this, we substitute back in the equation, we substitute back in the Laplace, so this becomes the Laplace inverse of 1 over s squared minus 1 is equal the Laplace inverse of minus half of 1 over s plus 1 plus half 1 over s minus 1. We can apply the linearity property of the Laplace inverse, and we obtain this minus half of the Laplace inverse of 1 over s plus 1 plus half Laplace inverse of 1 over s minus 1. All right, what next? We use the table of the Laplace inverse to obtain these 2 values. So the Laplace inverse of 1 over s plus 1 is e to the power minus t, and here it is 1 over 2 e to the power t. So this is basically sine hyperbolic of t. Okay, so it's simple, and you should be able to do that. Now let's look at this second example. So you basically have a fraction, and in this case we may not use a fraction decomposition because it's simple. We just have to rearrange this in such a way that we obtain what we already have in the table of the Laplace inverse. So this can be written as the Laplace inverse of 3x plus 5 over x squared plus 7 is, if you write this as the Laplace inverse of 3 times x over x squared plus 7 plus the 5 over s squared plus 7. All right, at this stage, remember that the Laplace inverse we know that the Laplace inverse of a over s squared plus a squared is sine of at, same as the Laplace inverse of s over s squared plus a squared is cos at. All right, knowing this, and here we have 7 and 5 here, I want to have the same denominator. So 7 is my a square. So basically a square here is 7, then a is root of 7, okay? So we can rearrange this as the Laplace inverse of 3 times s over s square plus square root of 7 square plus 5 over square root of 7 multiplied by square root of 7 over x square plus square root of 7 square. All right, here we also apply the linearity of the Laplace inverse and obtain 3 Laplace inverse of s over x square plus root of 7 square plus 5 over root of 7 Laplace inverse of square root of 7 over s square plus square root of 7 square. All right, we know this based on what I've given here. So the first one is cos 3 cos root 7t plus 5 over root 7 sine root 7t. This is the final solution of the Laplace inverse of this. So basically here you just have to put this fraction in the form that you already know, and we know that from the table of the Laplace inverse we have these two identity, okay? All right, let's look at this last example. Again, we apply the fraction decomposition here as we did for the previous one. So for the fraction decomposition, a square over x bracket x square plus a square is alpha over x plus beta x plus gamma over x square plus a square. All right, you have to cross multiply here to obtain the value of alpha and beta. And by doing that, I know this is high school problem, you should be able to do this. So you should be able to cross multiply and obtain the value of alpha, beta, and gamma. And following the normal procedure as we did there, you obtain alpha equal 1, beta is minus 1, and gamma is 0, okay? So the Laplace inverse here, the Laplace inverse of the fraction a over s square plus a square is the Laplace inverse of 1 over s minus s over s square plus a square. All right, linearity. This is linearity property. We have 1 over s minus the Laplace inverse of s over s square plus a square. Okay, what is this? The Laplace inverse of 1 over s square. It is 1. And the second part is cos a t. So this is straightforward, very simple. You should be able to do this. Right. Thank you.